Hello, everyone. I'm Ursula, second year just currently the YT school. Today I'll be presenting on directly exposure market to the other details communities in Korea. How are you? Does anyone know the current price of an ounce of gold? Anyone?
1,400.
It's currently 4,500 US dollars. The surge in gold prices makes artisanal gold mining economically attractive to miners despite all the health hazards it presents. There are two types of gold mining: large-scale mining and artisanal small-scale mining. With large-scale mining, it is capital intensive, it is heavily regulated, and it follows rigorous standards as seen in companies like Kennecott, Barrick Gold, and Ursula. And in artisanal gold mining, it is labor intensive. They mainly use handheld tools. It is informal, that means it is illegal, and they draw heavily on mercury and sodium cyanide used in the gold recovery process. Due to weak oversight and uncontrolled chemical use, they put themselves and the community they mine in. Artisanal gold mining contributes over 10% of mercury emissions worldwide, but it gives economic support to over 100 million people globally as well. The operations vary in size, production, and legality. They all rely on elemental mercury and cyanide for gold extraction. Elevated mercury exposure has been documented in continents like Asia, Africa, and South America. Mercury exists in three forms. Each form has its own health effect. When elemental mercury is used in mining, the body metabolizes it into inorganic mercury, and bacteria in the water transforms it into methyl mercury. Mercury is also known as quicksilver. It is liquid of room temperature, and it is highly volatile. That means it evaporates easily. There are three exposure pathways: dermal contact during or mixing stage, and vapor inhalation during heating of the amalgam, and when methyl mercury is consumed. This is how mercury is used in artisanal gold mining. Miners add large amounts of elemental mercury to the gold ores. The mercury binds to the gold particles in the ore, forming a gold mercury alloy spread in the amalgam. The amalgam is further heated where the mercury vaporizes using the gold. At this point, mercury is discarded into the environment. So the amalgam is a combination of mercury and gold. Mercury doesn't just disappear. When mercury vapor doesn't disappear. When mercury vapor and mine waste enter water systems, it transforms into organic mercury compounds called the methyl mercury, which then bioaccumulates in fish. The study had three main objectives. One was to quantify mercury exposure in biological samples, also to assess risk factors, and to investigate the relationship between mercury exposure and health outcomes. The study also fills important gaps by using biomarkers that's measuring elemental mercury in urine and methyl mercury in blood. They also used proper creatinine correction for the urine samples. And it was the first study to assess human mercury exposure in this particular region, despite all the knowledge they knew about the environmental contamination in that specific region. It was a cross-sectional study with 103 participants in a community called Way. It was conducted over 3 days in July 2010. They also drew their population or their participants from a 3-day health campaign, and they achieved 100% participation rate. Their inclusion criteria was quite simple. They considered ages 3 and above with over 6 months residency. They administered a structured questionnaire that covered symptom checklists and also took biological samples. All health assessments made here were all self-reported. With the laboratory findings, urine mercury, which indicates occupational exposure, showed 100% of the participants were all exposed, with an average of 5.5 microgram per gram per liter, which is 10 times higher than US population, that is the background exposure. With blood methyl mercury, which indicates dietary exposure, 91% of the participants were all exposed, with an average of 2.7 microgram per liter. They also reported some very dangerous levels. We had 8 people, that's 8%, recording levels that was above the ACGIH threshold, that was 35.5 microgram per gram per liter. For the analysis, 6 significant risk factors were identified. Heating amalgams and drinking from non-public water sources all showed an increase in urine blood mercury concentration. Also, fish consumption and higher education level also indicated or showed higher blood methyl mercury concentration. On the other hand, mixing mercury showed a lower blood methyl mercury concentration. This would indicate that they really didn't. Participants who had earlier on reported that they had kidney ailments also reported higher urine mercury concentrations. Also statistically significant. For health outcomes, the most common symptoms they reported were headaches, mood swings, muscle weakness, memory loss, irritability, skin allergies, peeling skin on hands, problems sleeping, and tremors. Amalgam heaters had higher memory loss than their counterparts who did not heat amalgam. They reported 67% versus people who did not heat amalgam, who reported 22%. In a global context, they made comparison with other mining regions. They compared median urine mercury among miners who heat amalgam. Their comparison showed that mercury exposures among artisanal small-scale gold miners was a global crisis and not something that was very specific to Peru. They also said that according to research in all these areas, miners heating amalgams had higher mercury levels compared to an unexposed population. For the key findings, there was a universal exposure. 100% of the participants, all of them had detectable mercury levels in their system, including children. Amalgam heaters also had significantly higher levels compared to participants who did not heat amalgam non-heaters. Memory loss was also recorded among amalgam heaters more than non-heaters. And 8% of the participants also exceeded the occupational threshold. That was 35.5 micrograms per gram. An unexpected finding that added to the crisis was drinking from non-public water sources. It actually revealed that there was another source that could be a pathway for mercury exposure. People or participants who drank from wells and springs had elevated mercury levels, both in urine and in blood. 4 key insights could be drawn from the paper. Multiple exposure pathways were identified. Amalgam heating, that's heating mercury and the gold particle stage, mercury vapor from that angle, and eating contaminated fish and drinking from unprotected water sources like wells and springs. The main risk here was heating gold mercury, that's the amalgam. And symptoms were already being presented. They complained about kidney and neurological damage as well. The most vulnerable people in that community were children of childbearing age, because methyl mercury has the tendency of causing the placenta and actually causing damage to neurological damage to the fetus. For the limitations, the study actually laid down some limitations. They said a convenience sample from a health campaign may not be generalizable. They acknowledged selection bias. And 8 people who were high risk were offered remediation. That's to be removed from the job completely or to undergo creation, but they turned it down. They did not accept the offer. The questionnaires they also administered were all not validated, and the symptoms presented were all self-reported. There were no clinical diagnostics available. The study had some key strengths as well. They had rare access to a remote mining community with full participation. And the biomarker data they had was of high quality because it was from the CDC lab. The international collaboration between the Peruvian Health Authority and the US CDC makes the study quite credible. And they had a very diverse population. They included children, women, and non-minors in the study. The study confirms community-wide contamination, with inhalation being the primary route of exposure. We also identified multiple exposure pathways. That's air, mercury vapor in air, in water drinking from unprotected water sources like wells, springs, streams, and also eating contaminated fish. These 3 pathways all require multi-level intervention. And also the economic dependence on the occupation, artisanal gold mining, prevents them from remediation. They could not afford to be off the job completely, and this could be due to poverty. They also made some recommendations. They recommended that there should be community-wide education, educating the people on the health effects and side effects of mercury use. And also, they talked about centralized amalgamation centers, that's building amalgamation centers away from residential and commercial areas. They also discussed the use of a retort furnace. The retort furnace actually traps over 95% of mercury vapor and condenses it back into elemental mercury that can be reused. They also talked about using less of mercury and also considering alternative methods to mercury-free mining. For my AI component section, I asked AI to give me the health impact of mercury on the environment and on human health. And I had this mini infographic that captured some of the salient points that was raised in the paper. That's it. It's what I have. Some questions and discussions. If you have any questions or thoughts, you can. My first question that I had was, they actually transported the samples they took from the participants from Peru to Atlanta. So my question was, how might sample degradation during transport from Peru to Atlanta affect the what quality control measures would be necessary to ensure samples remain stable?
No biosamples, are they normally transported in kind of like fills just or plain? Like are they refrigerated? I don't know that much about it.
That was what I was curious to find.
Yes.
And you just ask me about this, eat from that. Anything, excellent.
Are there any Ahmeds here that can answer that?
You mind repeating the question?
How might sample degradation during transport from a region?
Yeah, I'm sorry. I thought somebody else had changed it. So yeah, samples can definitely degrade. I think about blood actually as being worse, but I think urine is really what was used for my own study. Perhaps. Urine was that the
It was urine and blood.
yeah, blood can degrade really quickly. Honestly, I'm not as sure about urine, but urine is kind of similar to blood in some ways, but blood contains protein. Probably can degrade the sample for sure. So if it's not treated properly, it has to be like, for lack of a better word, harvested very quickly and spun and frozen really quickly. It needs to be frozen to a very specific degree, which I forget. I haven't used blood in a long time, but yeah, it can degrade really quickly.
That is true, although I'm not sure.
Yeah, that I don't know. Because metals are kind of different.
Yeah, I
right?
don't,
So-
yeah, I don't know.
But I don't know if it could potentially change whether mercury was organic or not. I guess that would be my real question.
It also depends on what you're trying to get. Like if you
Yeah.
know the volume of urine or volume of blood, and you just want to know how much per that volume is mercury. I don't know how much mercury will degrade or whatnot. I'm guessing it will remain. And so as long as you know that when it left the place, it had this much of that thing, if evaporation or other things happen, mercury's not going to evaporate. So you could still get a measurement of how much mercury was in a liter or whatever of the specimen. But again, don't know. How was it transported? Was it transported in a refrigerated or a climate controlled environment? Was it all those sorts of things can affect how that would then be measured.
They could have collected on like a portion of the container, for example.
Yeah.
Like settled.
Yep, for
I
sure.
guess my other question with the urine I think was compared to, mercury was compared to creatinine, is that right? They were comparing it to, was it creatinine to,
Yeah.
so in terms of, comparing it to what they thought was kind of the concentration of the sample. I guess.
Yeah.
I don't know, again, if that's something that could deteriorate and change, what the proportion is that they're looking for. And I guess, my other question is, I know some other studies have used creatinine to determine like concentration of urine, but it's not really the best marker. Like a better marker, I think, would be something like specific gravity. So I don't know if that would, again, affect the results. That wouldn't be degradation, but it potentially could be a problem with the study itself.
I have a comment more than a question. There's an area of research called behavioral toxicology, which has a range of methods that, cognitive tests, cognitive and behavioral tests. Some of them are computerized. So you can run participants through these tests to get a score that can be norm referenced against a non-exposed sample. So this study was missing a control site or a comparison city that didn't have artisanal mining, and those behavioral toxicology methods could be stronger in terms of indicators of potential neurotoxicity of the exposure before, without doing like brain scans and deeper neurological testing. So just so folks are aware, it is an interesting area of research for getting early indicators of decline in functioning due to exposure to chemicals.
I had a question, and I'm not a physician, I'm not a biologist, I'm not a chemist, I'm an engineer. So I know nothing about people. So, having said that, mercury, how is it stored in the body? Where does it accumulate? Is there anything you can do about it ever?
In the kidneys.
I'm sorry?
Kidney.
The kidneys, okay.
Mercury hierarchy in the kidney. That's what I know. And what I can do about that, using mercury-free mining, considering mercury-free mining, that's using better alternatives. I read something small about the use of sodium cyanide, which is equally toxic, but they considered that to be a better alternative to the use of mercury. And also it gave them a better yield because the gold ore is soaked in sodium cyanide for over 5 days, where the cyanide actually draws much of the gold particles. So it is a better alternative, but it is not the best because it is also very toxic. Yeah, but other companies use flotation and some other things, but I'm not a mining student, so I don't really know much.
Okay, thank you.
Yeah, I think I would just throw out that, the study is really focused on small artisanal miners. And the larger organizations in the mining world have a lot of controls in to manage mercury. And, mercury is referred to as the Mad Hatter's disease in the mining world, right? So, but anyway, yeah, it's interesting to see from the artisanal standpoint, the smaller operators. But in the larger context, there's a lot of controls to make sure that those health impacts don't occur and environmental impacts.
So I don't think they talk about it in here, but, and this is not a question just for you or just for the room, really. Are there any low cost or free intervention type things that could be done for these could be promoted among the artisanal mining groups that they could implement? Because I think probably the biggest issue for them is going to be the change from mercury to to other processes is going to have some costs associated with it, and they don't have the money to do that, or they claim they don't have the money. Maybe they do, but regardless, are there any options for them that are not going to make it impossible for them to do it? Because because the alternative, as you were talking about earlier, for people to work with those folks is poverty or worse poverty, or continue being exposed to mercury, right? So are there any interventions that would allow them to keep working that their companies would be interested or willing to even consider? And does anyone know? I mean, I think that's the barrier here is if there is something that they could do simply to change that, there's an opportunity there. If there isn't, then that makes it a much harder thing to
maybe government interventions,
Yeah.
building
Yeah.
an amalgamation center where that would be away from residential and commercial areas because they all had high mercury levels in their system. That means they had furnaces scattered all over the place that had mercury vapor all over the place as well. So putting all the amalgamation centers away or building an amalgamation center away from people and using technologies like the retort furnace, which I believe would be expensive. If there are government interventions or if there's an intervention from the government to help the people, I think they could build that for the community to actually save them from the crisis they are in.
Okay.
Kind of to go off that, are there forms of cheaper like PPE that could be used as well, or is it just they inhale it, it's on their skin, there's not much they can do about it?
For the mercury vapor, I think it would be a respirator, but they were even offered a chelation process, that's a medical process to actually help them, but they turned it down. So trusting them with PPE would be a bad idea.
Anything else for Ursula? Going once, going twice. Gone. Good job.
So, the paper that I'm going to be talking about is a radiographic correlation of symptomatic and asymptomatic flatfoot and young male adults by the following authors, and this was published in International Orthopedics in 2008. So flatfoot has been considered an exclusion criterion for military service for a very long time. It's actually been identified as an area of concern as early as the late 1800s. The rationale for why this has been the case has changed with time. Obviously, in the late 1800s, most of combat was done on foot. You'd be in the trenches, you may be carrying something well over 50 pounds. So the concern was more evident. But initially, the rationale was actually focused on concerns about inefficiency during marching and not any tangible sense of injury for the people involved. Are you talking, guys? Okay. So with time, this has actually evolved into concerns about arch pain, blisters, and lower body musculoskeletal disorders as well. And if you look at countries with conscription, they tend to have very clear standards. And they usually broadly gesture towards this idea of an elevated risk of injury without really elaborating on what that means. And one thing that does generally get discussed in these circles is whether or not somebody who initially doesn't have any symptoms like pain goes into the military, gets exposed to who knows what, and by the end of their service, it actually transitions into a presentation that does have some amount of pain. And whether or not the VA wants to handle those claims, those have been filed demonstrably showing that their feet have changed between the time they got recruited and the time that shifted. With that said, this type of discussion tends to be mostly of interest in countries that have conscription, not only because they are exposing a large portion of their population to potential conditions that might cause some form of injury, but also because they have to do these evaluations on whether or not people are at risk in both. This is an example of the line that the recruits have to go to when getting conscripted in South Korea for their medical. With all of that said, there isn't really any consensus on how flatfoot generally is classified. Most of these definitions tend to be based off of functional exams or tend to have some baseline assumption of pain or that surgical intervention of some kind is necessary. So it tends to be very clinical. Nevertheless, there are several definitions that people use to diagnose flatfoot on a quicker basis. A lot of these involve physical examinations. You can see right here for this individual, you just look how there's not an arch in picture A, but when you move their toes up, there seems to actually be an arch. Or I guess the less involved way of looking at this is the ink blot test, which is exactly what it sounds like. You have ink, get the footprint, and then you look at the surface area to make determinations, which is mostly historical, but some countries still elect to do that now. The last one is radiographic measures, which is basically popping people into x-rays and then looking at key angles of different joints, which is what this paper is going to be focusing on. So the tolerance of flatfoot, or whether or not it's a symptomatic presentation or an asymptomatic one within certain levels, does vary by country with conscription because they're transparent about how their processes work. But it generally does hinge upon some assumption of prior symptoms, like saying that people have pain, and also the perceived severity of that condition based off of whatever definitions they provide. These are also rather variable. Even if you have this delineation between somebody who already has pain and somebody who doesn't, there isn't very much information on how flatfoot is being classified with respect to morphology, which you can see right here, or even the underlying biomechanics of how these joint loading profiles differ. So this paper essentially tried to examine whether or not, if we use a radiographic perspective, whether or not you could tell, just looking from these, whether or not somebody is an asymptomatic or a symptomatic presentation of flatfoot, specifically using the paper Younger et al. Even though the original paper they're basing their metrics off of is using more than just a lateral perspective, like you can see here, The author said that they elected to only look at the side perspective because it's apparently a very frequent thing that they do at the military clinic that the authors happen to work at. So, as part of their data collection, they looked at 25 male Turkish army recruits with diagnosed flexible flat foot. And they did lateral radiographs like the ones that you saw here. Here's an illustration of what that looks like, as well as the relevant angles that they examined. The first of which is the talus metatarsal angle, which you can see right there in magenta. And that is essentially looking at the projection of like this long axis of your talus right here, and which is also being aligned with this guy as well, which is going off of the long axis of your first metatarsal, and then comparing those two alignments. The second one is for your calcaneal pitch, where you have your horizontal line, just basically the floor reference, and then looking at the lower aspects of your calcaneus, which is your heel bone, and measuring that difference. So with this paper, they did provide some pretty rigorous classification or explanation on their classification for whether or not somebody constituted as being a flat foot case. In especially military-centric literature of this nature, it tends to be a little more hand-wavy in their approach. So I do appreciate that they did provide a step-by-step explanation on how they did it. So for the first half, they had a physical examination. So people would be in a weight-bearing position, pretty much just standing on their foot. And while they were standing still, they looked for whether or not there was an obscured medial longitudinal arch, which you can see right there. That's like the opposite of an arch in this case. And they also checked to see whether or not their forefoot was abducted. So if these are my feet, they're kind of going away, like the front portion is kind of going away from the midline of the foot. And then there's also heel valgus, which is what you can see right here. There's sort of an inward collapse of the like ankle joint complex. If they had all of these characteristics, then there was the tiptoe test that they had to then perform, which is pretty much like this, except on your tiptoes. Whenever they went into this position, there had to be a reconstruction of the arch, like you can see in picture B, as well as heel supination, which is kind of like a inward collapse of your ankle joint to try to maintain that position. A healthy individual would just not really exhibit any strong supination or pronation in the standard case. So the next thing that they put a bit of info on was exclusion criteria. It was very in-depth. They said that you could not have Achilles tendon contracture, any dermatological conditions of the foot. Apparently this is because one of the co-authors happened to also be a dermatologist, as well as neurological or congenital foot conditions, and then any known prior lower extremity surgical interventions that could change the morphology of the foot. So with that said, that is actually supposed to be the total number of individuals. The mean age range was 21.5, and then the full age range was 19 to 30 years of age. Of the individual feet that were scanned from these 28 individuals, there were a total of 24 feet that were considered asymptomatic or pain-free, and then 32 of the feet that were considered having some amount of pain. And they clarified what types of pain had to be identified beforehand. So during military marching or running and any sort of exercises, the individuals had to previously specify that they had medial arch pain, foot, ankle pain, or calf pain. And then apparently on the side, after this was done, somebody, presumably the clinician, stopped them, and then they looked at point tenderness along the plantar arch. So I assume they just poked at their feet and asked them if it hurt. And once they had identified these individuals and sorted them accordingly, for the statistical analysis, they did a chi-square test to, quote, compare the groups, as well as a Mann-Whitney non-parametric test to look at the joint angle comparisons between the two conditions. Then there was a logistic regression to look at the risk factors with respect to the joint angles, and then the probability of, that's a fun word to say, symptomatology. And for all of this, they had an alpha value of equal to 0.05. So if we look at this table of the results right here, if we first focus on that talus first metatarsal angle, you'll see that in the symptomatic presentations or painful presentations of flat foot, there is a greater angle difference between the talus and then the metatarsals. In contrast, for the calcaneal pitch, the asymptomatic instances had a greater amount of calcaneal pitch relative to the symptomatic instances. And in both cases, these were considered statistically significantly different from one another. If we look at the results from the logistic regression, this is only showcasing, and this is their only graph. For the talar first metatarsal angle, you'll see that that one was considered very statistically significantly different. And the calcaneal pitch just barely did not end up making the cut to be significantly impactful. But essentially, they found that the greater the angle difference for the talar first metatarsal, the greater the amount of risk. I believe off the top of my head, it was 2.41 increase of having a symptomatic instance compared to an asymptomatic one. So the authors ultimately concluded that the talar first metatarsal, the two joint angles pretty much, both demonstrated that there was some statistically significant differences between the asymptomatic and symptomatic presentations of flat foot. With the talar first metatarsal's ultimate goal looking at talar inclination, so just kind of a forward-backwards orientation, as well as hind foot pronation, which is basically the hind foot kind of tilting a little bit out this way. And they found that this angle was significantly greater in your symptomatic presentations relative to your asymptomatic ones. And the CP angle focusing on hind foot alignment, so pretty much your heel, ended up demonstrating diminished angles if it was an asymptomatic presentation, although the effect doesn't seem to be as dramatic compared to just looking at the talar first metatarsal joint. So the authors then concluded that using this information, this could be used as a baseline for appropriate means of orthotics or insoles management and or surgical interventions as necessary. If we kind of move on into the strengths and weaknesses of this paper, I will say that this is a very thorough explanation for how they classify their participants and also how they excluded these individuals. It also has, from my perspective and considering the logistics, a pretty decent sample size as far as collecting radiographs. That I guess is the one benefit of having to screen everybody is you have a larger sample to pick from, as opposed to areas that do not. Let's see. Since this paper was published in 2008, this was actually one of the earlier attempts at trying to evaluate flat foot using a quantitative perspective that isn't a strictly clinical one. The intent is ultimately to kind of look back at the military context and see whether or not there might actually be some tangible differences there. So they were to try to make these delineations. This is also one of the few papers that also examines asymptomatic adults. Most of the papers you'll find in this area tend to be focused on people who already have pain and thus usually require some sort of intervention, usually surgical. Thus, that's why it's in your surgical journals. They also tend to also be focused on pediatric presentations. So an overwhelming majority of flat foot research is focused on kids and how that changes with time. The flat foot of a child is going to very much be different from the flat foot of an adult. So I do find it interesting that this has not been explored as much as other areas. As far as weaknesses go, well, they don't really talk about their perceived strengths, weaknesses, and general limitations. There were no female participants. They do acknowledge that much. And there was also what they consider to be a limited sample size. I think when it comes to evaluating stuff politically, there is a different standard. To be fair, there is a more recent publication that released 500,000 individual foot scans from South Korea looking at this exact thing. So I guess in the grand scheme of things, this could be small. Still a pretty decent size, in my opinion. One other thing to consider is that this only looks at 2D radiographs. You might not have noticed until now, but the foot is a 3D object. When you have these scans, they can only tell you so much. When you look at the metatarsals, they honestly all kind of bleed into one another. So it really does take a clinician to be able to figure out whether or not these are sufficiently reasonably representative. So a 3D reconstruction obviously would have been better. They also did not consider anything that was non-lateral, like an overhead or even like from a backward, like a posterior view. Even though in the original paper they did look at these other non-sideways perspectives. So I found it interesting that they did not decide to include that. One other thing is that they also didn't really explain their statistics. The section is very short. They had a chi-square test, and maybe this is me not fully understanding what a chi-square test does. They don't actually say what they put into the chi-square test. If anybody wants to look at that and let me know, that would be fantastic. They just said, we did it to compare the groups, and then they have a p-value. But I assumed it was the joint angles, but they didn't say. So yeah, they also didn't really talk about any sort of quality checks for their analyses to make sure that they were appropriate. They just kind of put things into logistical regression and assumed that the data would fit those parameters. So that was interesting. One thing I would also like to highlight, but it's not necessarily a weakness, is that in their final recommendation, they suggest only looking at the talo first metatarsal angle for the results and making an interpretation on flat foot, even though they acknowledge that the calcaneal pitch was also pretty okay. So I don't entirely know why they didn't think of considering just both in conjunction, because there are some trends that seem to be occurring. Lastly, and this is kind of small, but they don't actually explain how they obtain their radiographic measures. Because you're looking at these X-ray images, there is a little bit of concern for inter-assessor reliability, which is honestly pretty commonly addressed in this type of work, and they honestly just did not address that at all. So, moving on to the last bit, I have some questions for everybody. I talk all about flat foot and why it may or may not matter, but I do have to ask, should flat foot still be considered like a risk factor for the military if there's arguably less and less of a need for military personnel to perform long distance marching? Obviously, in the late 1800s, World War I, World War II, et cetera, very different landscapes to what we have now, maybe. I would love people's thoughts on that. Another thing is whether or not it's appropriate that we should be looking at one angle to try to make a diagnosis for flat foot. And maybe should we make some specific wiggle room for the military itself because it's the military? Is it appropriate to do this in general since most people don't really get foot scans? The next question is, they do acknowledge that there are no female participants. Do you think there would be any noticeable differences in male to female recruitment or recruit foot characteristics or possibly in their risk profiles? And given that there seems to be a long-term potential for injury, happy to talk about that later, should flat foot be automatically screened for in a more qualitative manner, more than just going up on your tiptoes and looking at it as just part of the general military recruitment process? It has been done before in a few different countries and still is being done.
Yeah, I'll offer some thoughts on that first question. As occupational medicine physicians, one of the aspects of our job is to do fitness for duty evaluations. And as like an example for firefighters, right, we need to contextualize their health concerns and issues as like, will this person be safe running into a burning building, right? And sometimes, you know, we come across firefighters who are later in their career and maybe they have a little bit more pathology or disease, but they're also like, hey, I actually do mostly administrative and office work. However, there is always the chance that they will need to respond to a call, and we have to put it into that context. Will this person be safe in that environment? So while there is probably less of a need for military personnel to engage in long distance marching, if I am like doing a fitness for duty evaluation and there is the remotest chance that this person's going to be put into a context where their life is in danger and they have to be on foot, then I have to take that into context. So I guess the answer is maybe it still should be seen as a risk factor, but you know, it is very much job dependent.
So one thing we're talking about in IO psychology class right now is job analysis. And so one of the things that military has done in the past, I'm not sure how recently they've done it, is they do job analyses to verify, okay, here are the tasks that a patrol, officer, patrol person, would have to have if they're going to be doing whatever they're going to be doing, right? And so if they're continuing to do that, there may be a shift, right? It may be that we have less personnel who are going to be likely needed for such an activity, right? Such a process, such a task. And so as those job analyses change, then the processes that are expected by OM docs for fit for duty would also need to be changed. The issue though is sometimes those processes, those things, those changes they make over here don't get communicated over there, right? In fact, it probably rarely happens that they get communicated across these groups. And so I think that's part of the challenge with any type of change to duty that happens for whether it be military personnel or firefighters or any type of job is once you change those duties, what are now the exposures that they have that they didn't have before that now need to be considered when hiring a person, working with people, working with what they do. So, yeah, so my answer would be, let's look at the job analysis. And if this job requires it, then the fit for duty screening and so forth needs to include that. If it no longer requires it, then it doesn't need to include that anymore. I looked at the chi-square. The issue isn't that they didn't. The issue is I don't know what they compared. They compared the groups, but they didn't say on what.
Yeah.
Right. So they do have the chi-square in there, but they have lots of different measurements that they took, and I can't tell you which one they were comparing between the groups.
I took it
Could
to
you?
mean they were just testing whether the proportions of symptomatic or asymptomatic
Oh, okay.
were different, which is a pretty uninteresting.
Yeah, if that's what they were
Question.
comparing, then
And then
okay.
their note on power was also,
Yeah.
we used G power and it was set to 0.82. I don't,
Yeah.
it's unclear that they knew what they were doing when testing power
Yeah.
analysis.
Yeah. I don't. I'm not confident in their.
So I
analysis.
think the question is that whether or not they were symptomatic or asymptomatic was kind of a coin toss. It was roughly 50-50. It wasn't proportionally one way or the other.
Yeah. Yep. Okay.
All right, so I'll agree with all y'all. So as a person who has done the marching before, it comes out to be sometimes more than just the risk of actually doing marching for long distance, because you're not marching battalion or like that. What it winds up being is more of a disciplinary way of doing things, is to train the people to be more disciplined in the way they perform and the way they do their tasks. It sounds very simplistic, but it is actually a way of training the individual that this is precision that you're doing. Many recruits, and having taught recruits, they always say, why am I doing this, or this is dumb, or those kind of things. It usually is because they need to understand that it's not just the fact of doing this marching, but it actually applies to all the jobs that you do, the discipline that you need to have to be able to accomplish the task. Now, could it be better screened, as in your last question there? Yes, actually, I think that's and I believe the military is moving towards that direction to do better screening on that base than the baseline way of doing things back in World War II or Korea, Vietnam. But it is also a matter of discipline.
It's a great question to be asking, though. I love the question. Is it still functional?
She's kind of cheating.
So for your second question, I don't really think that one angle can really be considered like a good diagnosis for this. I mean, this was made in like 2007, but I don't know how long this has maybe been a preferred like way to measure flatfoot. And I would like to know if you know of any other ways as well, but I guess looking in the frontal plane at anything as well, any like ankle twist or like any way that you can determine if like the ankle joint or tendons are any way compromised. But I'd like to hear maybe anybody else's thoughts or your thoughts on that as well.
Sure. So since the standard for what constitutes flat foot is pretty vague, there isn't anything super definitive. With that said, South Korea is one of the two countries that I'm aware of off the top of my head that does radiographic measures for every person that indicates flat foot. It turns out if you're getting conscripted, you're going to list every single thing that might get you off. The person who wrote that paper wrote that very passive aggressively. It's very funny. I have it framed. Basically, they actually have, well, 3 different angles, and depending on the classification of severity, usually it's two of the angles have to hit. I can't remember them. I think one of them is calcaneal pitch. But the other ones are functionally rather similar. It's still a sideways lateral radiograph. Yeah, they have to tick at least 2 of the boxes of the 3, and which of the 3 they have to fulfill will depend on whether or not it's like a moderate, a severe, or a mild. So that still doesn't fully capture what exactly is going on in the foot. The 3D methods are the way to go, but it's still fairly novel in the grand scheme.
And I guess like to follow up for that for like military personnel, like what could orthoses do for people in the military? Is that where people are like generally looking towards going, and does that reduce their pain or their risk factor of getting injured?
You know, that's a great question. Nobody has decided on an answer. It's I would say like the 70-30 split on there is a risk versus no, there is a risk in general. So one fun fact is in World War I, we were like, yeah, anybody with flat foot is fine. We'll just give them a pair of insoles. And then that backfired. Pain from flat foot was actually the second leading cause of honorable discharge for that war, with number 1 being tuberculosis. So it actually is a big deal. Obviously, the tech has changed quite a bit since World War I. There are a lot of studies that try to figure out what characteristics of an insole work really well. But I think realistically, unless you can implement custom insole design for people at risk and get that done quickly and in bulk, and it's not going to break the bank, I don't know how realistic that would necessarily be in terms of implementation, even though that would be great if you could.
Kind of a random question. Do you know like a per capita percentage of individuals that experience flat foot, and like what portion of the population would be represented?
That's going to vary by country, but the one big challenge with flat foot is that a lot of people either think they have flat foot and don't have it, or yeah, they have flat foot and they don't realize it. There's actually another paper also from South Korea. There's a bit of the theme with speakers from South Korea. That was actually about self-perceived accuracy, whether or not like somebody considered themselves as being flat foot and whether or not they actually were. It turns out there's actually quite a rift. I think, let's say that people don't know what their feet actually are.
Is it something that people are generally born with, or can it come from injury to the foot? Is it mainly just when like the tendons underneath the foot are generally like looser? Could you expand on it more?
That's a great question, and there are a lot of people in pediatrics that are trying to answer that. The shape of your foot does change as you get older, and one of the influencing factors is whether or not kids are introduced to shoes at a young age. The question is, should people have arches, is actually surprisingly contentious, and you'll find papers from an evolutionary perspective that say no, but then from a clinical perspective will say yes, and they don't agree with each other. So it's actually surprisingly complicated. There are certain conditions that have a predisposition for flat foot, like cerebral palsy, but usually in those cases, it tends to be comorbid with something that's a little more spicy, if you will. So your flat foot, your gait is modified, but it's probably not just the fact that you have flat.
So when you say that like it depends on shoe wearing, are you saying there that if you start wearing shoes at a younger age, you're more likely to have arches?
That's I don't remember the exact relationship off the top of my head, but I'm pretty sure if you wear shoes, you do develop arches. I assume this has to do with the fact that you have some amount of cushioning that may or may not be present when you're wearing shoes. So it is kind of, in a way, it's kind of cultural. To tell you. Cut that from the recording.
All right, great job.